NASA's James Webb Space Telescope has finally launched. After 26 years of design and production, the most powerful telescope ever is about to start transmitting its first images. It's designed to study the very early universe, just after the Big Bang. Costing around $10 billion, it has the potential to reshape the way we see the cosmos. Join us as we tell you about why the James Webb Space Telescope is changing our perspective on the stars. For starters, what will James Webb do that Hubble can't? You might be asking yourself, we already have Hubble, why do we even need another space telescope? Well, for starters, Hubble was outdated before it even launched. There's still a lot we don't know about the universe, but back when Hubble was being designed, we knew even less. For starters, we didn't know that things like galaxies and stars were already around just a few 100 million years after the universe was formed. But there were other problems too. Astronauts discovered that stars formed this early back in the 1980s, and so it became clear that Hubble wouldn't be able to study this phenomenon in the way that scientists needed. But by then, the launch date of 1990 was closing in fast, and the project was already over budget and behind schedule. So it was decided to immediately begin work on a second, much more powerful observatory, the James Webb Space Telescope. The technology that makes the James Webb Telescope so special didn't exist back then at all. One of the biggest missing technologies was a viable infrared detector. These detectors existed in the late 80s, but weren't advanced enough to do this kind of work. Hubble can only detect visible light and ultraviolet light, but to analyze the early universe, you need to be able to look at infrared light. That's because due to the universe's expansion, these early galaxies are so far away from us that any light they emit is redshifted into the infrared spectrum. Now technology has advanced so far that the James Webb Telescope has multiple 2000 by 2000 pixel infrared detectors on its giant mirror. This will allow it to precisely figure out the chemical composition and age of an ancient galaxy. That's something that just wasn't possible with Hubble. Next up, James Webb will look at the chemical composition of galaxies. According to scientists, the early universe had a very different recipe of elements to choose from than what we see today. The only elements in existence at that time were hydrogen, helium, and lithium. Over time, all of the various elements that exist in the modern universe came into being through chemical reactions inside early stars. James Webb will be able to take a closer look into these chemical reactions using its spectroscopes. This way, we'll be able to figure out just how we went from just 3 elements to the entire spectrum we see today. Astronomers had this capability before, but only at the galactic scale. With James Webb, they'll be able to analyze individual objects for the very first time. With its infrared detectors acting as a superpower, the telescope will be able to see through the space dust to look directly at nebulas and galaxies. Since it's not limited to the visible spectrum, it won't have to deal with all those pesky visual obstructions that Hubble does. James Webb will allow astronomers to map out the formation of stars in far-off galaxies. Olivia Jones, a JWST scientist, told Space.com that we'll be able to see more extreme galaxies, where the environmental conditions are very different from the Milky Way. Jones added that while before we could only study the formation of stars several times larger than the Sun, now with James Webb, we can finally do the same for stars similar to our own. But what about things a little closer to home? JWST isn't just going to be looking at the farthest reaches of our universe, it'll also more deeply explore our own solar system. Mark Makarian, the European Space Agency's senior advisor for space exploration, also told Space.com that while James Webb can't analyze our own sun, the team would be looking at all planets like Mars, Jupiter, Saturn, Uranus, and Neptune, and the Kuiper Belt. The Kuiper Belt is the asteroid belt beyond Neptune's orbit. It's usually very difficult to observe because of how little light there is in the region. But according to Makarian, JWST will change all that. JWST can do fantastic spectroscopy on the Kuiper Belt objects, he said, saying that these objects reflect very little light, so the infrared detectors on the James Webb Telescope will be able to see them much more clearly. Next, James Webb will also be analyzing exoplanets. Just like with Hubble, between the James Webb Space Telescope's design and launch, new discoveries have changed the way we look at the universe or go about studying it. We first discovered planets outside our solar system orbiting another star in 1995. Since then, we found thousands of exoplanets, some within the habitable zone of their star. These exoplanets are crucial to understanding our own solar system and possibly looking for life in other worlds. But so far, these discoveries have been completely based on indirect evidence, like a star dimming when a planet passes by or changes in the gravitational axis. With the JWST, we can look at direct evidence. While the JWST wasn't designed with conducting exoplanet research in mind, it turns out that the telescope's perfectly capable of not just looking at each of them in detail, but also discovering many unknown exoplanets. The atmospheres of these exoplanets are made up of different molecules like carbon dioxide and oxygen. And again, the best way to analyze those is using infrared spectroscopy. One instrument on the JWST is its near-infrared camera, which works by blocking out a star's light to more clearly see what's happening near it. That means we can see the atmospheric makeup of different planets in detail and maybe use that to figure out whether they can support life. No one thought this would be possible just a few decades ago when Hubble was in its planning phase. Now, it's become routine routine, and JWST will help us do it better. What's more, the majority of discoveries will probably be completely unexpected. Like Hubble before it, the James Webb Space Telescope will completely revolutionize the field of astronomy. But the really exciting part is a lot of what we will discover with JWST is going to be stuff we don't even know about. Randy Kimball, a scientist working on the JWST at NASA, said that the reason that Hubble is so important and why JWST is so important is their generality. While they were both designed for some very specific mission goals, their range of capabilities was purposely made to be far more general purpose. That way, they can make discoveries in areas completely different from what they were originally designed for. And with how powerful James Webb is, it's capable of doing a lot more general purpose work too. With Hubble, Kimball said, if you look at its top 10 discoveries, half of those are things people had no idea about. So that's why the whole team working on JWST is so tense for everything to go as planned, because chances are we don't even know yet what the most important discoveries the telescope will make during its life are. Finally, here are all the different instruments that'll help the James Webb Telescope on its mission. There are 4 main instruments that help the James Webb Space Telescope perform its research. The first is the near-infrared camera, or NIRCam. The NIRCam is the most important instrument for the JWST's main purpose, capturing the light emitted by the earliest galaxies and stars. It consists of a very powerful infrared camera, but it also has a special group of components called coronagraphs. The coronagraphs have been specially designed to block out the light from a given star, which will allow astronomers to look at things around it like exoplanets. Next, there's NIRSpec, the near-infrared spectrograph. NIRSpec will take the light coming in from these galaxies and split them into spectra, which will reveal crucial properties about them like their chemical composition, temperature, and mass. And because observing one galaxy takes a lot of time due to how little light is coming from objects so far away, NIRSpec will also be able to observe 100 galaxies at the same time, making things a lot more efficient. Then, JWST has the mid-infrared instrument, or MIRI. MIRI's made up of a spectrograph and a camera, but it focuses more on the mid-infrared range of light. Observing these longer wavelengths will come in handy for astronomers that want to study things like asteroids and baby stars. This instrument has the most similarities to the camera on Hubble. Finally, JWST also comes with something called the Fine Guidance Sensor / Near-Infrared Imager and Slitless Spectrograph. The FGS / NIRISS's main function will be to spot the first light and also to detect and observe exoplanets. So, the James Webb Space Telescope comes loaded with specialized instruments that will revolutionize our understanding of the universe forever. That's a wrap for this video. Are you excited about what the scientists can do with the James Webb Space Telescope? Let us know in the comments below. Make sure to give this video a thumbs up and subscribe to our channel for more videos like this. See you in the next one.